Well, quick review of what happened last class. We attempted taking the derivative of exponential functions.
Oh yeah, with.
Right, remember that? And look what happened. When we try to take the derivative of an exponential function at some point x, this is notation 2. This definition is what we used. And we used it because we believe in this, sum of powers to a product of terms. You see? I'm going to mention a few other things that, who knows, maybe I'll mention something confusing. But we kind of believe it from previous classes in mathematics that we can carry out this factorization even when x and h are not integers. And that allows us to factor out a to the x out. It's not dependent on the limit, and we end up with this limit. This limit we did not figure how to solve, but it represents the derivative of my original function at 0. So far, so good. If it exists, it represents the derivative at 0. So instead of solving, I solve it symbolically. I just say, well, let's pretend this is going to be some number, and I'm going to have this labeling for it because it's the derivative at 0. I'll say f prime of 0. And from there, I see that the derivative of my function is my original function multiplied by the derivative at 0. That does not usually happen. Make sense? And if you actually paid attention before, if you were very, I can't remember the word, aufmerksam in German, meaning attentive, I guess. Yes, if you were attentive in your previous classes, you might have noticed that you solve equations like x squared equal to 25. And then you gave solution something like x equal to plus or minus 5, right? And 5 seems like a definite number. It seems rather concrete solution. On the other hand, you had equations like x squared equal to 5. And then you gave solutions which are plus or minus root of 5. And in school, I mean, I'm not sure how much you liked mathematics then. You kind of did something and the teacher patted you on the back of your head. If it is allowed, now it's not allowed anymore, right? You see, now you cannot, you have to keep your arms like this. You have to keep distance, and not just because of COVID, right? You don't love your students. So then this was the solution that was supposed to be given, and you got full score. But if you think about it, what is this saying? This is not saying anything that's different in here. This is saying a number that when multiplied by itself or when squared gives you 5. You understand? So when you have this extra symbol, it does not show you how to do the calculation. And the proof of that is, well, without a calculator. Can you tell me what that number is? Pavel, glad that you made it. I was worried about you.
Sorry, I had a quiz I had to finish.
No worry, no worry. I'm just glad you made it. You say I need the students that support me mentally. Right, that I look at and I think, okay, those at least understand something. Yes, yeah, here we go. And now she is there. Minkowski, good that you are here.
So I heard the shout out in the beginning of the class, and my sisters are all standing here, and they're like, "You have to turn your camera on right now."
Yes, well, you would see later in this lecture that again you are special today, right? You will see why, mathematically special. So you have it's not by coincidence that you have that correct name, right? Minkowski, by the way, you should read his biography, or at least some part of it, right? He's a funny guy. Okay, so you understand, guys, my rant about the root of 5. Right? Don't just think, oh, this old man is just blubbering in some strange accent. You understand what I'm talking about, right? I'm trying to revitalize your existence. I'm trying to see that you will breathe. Mathematics is breath. So this is a similar solution, right? What you do is instead of actually giving a solution, you give a name to the unknown. And if you can give a name, it's like you have a control. You took control of that spirit. That was even ancient belief, right? If you can name something, then in some sense you have achieved your first victory over that something. In the Bible, by the way, right? How is Adam Adam, right, is mentioned as the ruler I'm not sure if you call it ruler, but definitely the keeper of the Garden of Eden, and he named all the animals. Right? What is this all about? Why is it so important that he will name all the animals? Because naming gives you control. And that's what you have here, control. Good. And so we played with some particular derivative. So we wanted to find the derivative of 2 to the x. And we realized, well, if we could find the derivative at 0 of 2 to the x, then we know the derivative of 2 to the x globally. And because we could not calculate this limit, we plugged in a number where h was small, because limit means that h is approaching 0. It's a better and better imitation of 0. And if you can not continue making a better and better imitation, you just plug in some imitation that you consider to be good enough. Good. And you plug it in your calculator and you get this value. You plug again this value for 3 to the x and you get this value. So one thing is below 1 and the other thing is slightly over 1. And you realize that if you could get the derivative equal to 1 exactly, then wonderful. If you can make it equal 1 exactly, that means that you have a function whose derivative is equal to itself. And that was the hypothesis, right? The hypothesis is that there will be some number between 2 and 3 where this limit equals to 1. I should again, I mentioned this in the remark, is that it would bother me if you think that I was able to calculate it, because am I able to take 1,000th root? What is the calculator truly doing? If I don't understand that, I'm not going to accomplish it. By the way, I can show you a very simple, something that you should have, possibly could have come up on your own. If let's say I asked you to figure out what is root of 2, give me numbers, and you don't have a calculator, what would you do? I can show you a very simple thing, very, very simple. There are many things that you can do really, right? But very simple when you can calculate roots. If you're interested and you remember that, you can ask me after class. I bet, of course, you will all leave. Goodbye, have a good weekend, and so you're not interested. But you see, calculating roots, I remember one time people were not interested in it and I was irritated. I said, so then you don't care if I drop a brick on your head. And then I explained to them why that would not be. If they don't like roots, they don't mind if a brick is dropped on their head. If you're interested, then we can talk about that as well. Strange. Well, and that's the question. How do you know it could kill you? If you don't care about it, what happens to you, or whether or not I'm to blame, has a lot to do with square roots. If you're interested in that, I will explain. It was one of my good lectures. Don't worry, I will make it a very big brick. It's also, you know, it's very fitting. If somebody is very stupid, you don't want to kill him with some hot and sharp weapon. You want to use something blunt, like a frying pan, like this, right? So, yeah, so similar is with the brick. Yes. So you are with me, guys, yes? So there is this problem. I just couldn't help but mention it. But aside from that, you know, you plug it in the calculator, some numbers come out. And here is this thing. Here is this thing where you see, basically I realized that I am interested in finding solution to this differential equation. In other words, I tried to ask what function, when you take its derivative, equals to the function itself. And I make the extra condition, the function at 0 is equal to 1. Now, I mentioned this in office hours, and I figured it's a nice illustration. You see, when you have some experience with mathematics, you realize that you realize what to pay attention to. You realize when you see such a thing that it's very important. Now, let me try to explain to you why. You all watch the movie Ghostbusters, like the old one or something, right? No, but you know what it is about. It doesn't matter. You know about those you know what's a poltergeist, right? So a poltergeist, you know, somebody, you have this horror movie or something, right? You have this spirit that invades the house and it wreaks havoc. And it throws the dishes, it opens the closet, it destroys the refrigerator, it puts the piano on top of the table, right? And you are all terrified with everything that happened. Now, if you are an intelligent poltergeist hunter, what do you pay attention to? You pay attention to what was not touched, because what was not touched is the key to understanding the poltergeist. Let me explain to you with another example, okay? A real example, in fact. And if you heard of it before, it's pretty famous. Then don't spoil it for the other people, okay? If you heard of it, of course, right? Then you can tell me at the end. So here is, and some of you, of course, were in office hours. You heard it already from me. But during World War II, a mathematician was asked to analyze damage incurred by aircraft. So you have this bomber. This is a bomber, guys. And the question was, where should extra armor be added to the bomber? You understand what I mean? And to make the question very trivial, I will divide it into 3 sectors. You understand? So here is sector 1. This with the wings is sector 2. And this with the tail is sector 3. So imagine you inspect the airplane, and here is what you see. You see that you have more damage to sector 1. Okay, you are with me, guys? More damage to sector 1, and some damage to sector 3, and no damage to sector 2. Now in the comments, write to me, where would you advise to add armor? Okay, those are the airplanes that came after sorties. That's where they were damaged from flak. Right? Your question is, where do you add the armor? Of course, if you don't know it, that's best, right? Because if you heard it, it's like spoiling the fun. So let's see. Oh, Rafid, yes, you're very funny. True. I do need armor on myself, but back to this question. People do try to kill me. Some people wish me quite a lot of harm, and they are living right next to me usually. You understand? Don't think of the airplane, because let's say this is what you understand. There is more damage to the front, there is damage in the back, there is no damage here. Where do you end the armor? Dante says 2. Okay, some people heard of this question before. Yeah, yes. What about the rest of you? Do you understand? I mean, I'm asking, just here is more damage, here is more damage. Where do you add the armor? Simple question, yes? What about the rest of you? You crashed with your airplane on some mountain. That's why I don't see you. And busy eating other people, right? As to survive, not paying attention to the lecture. Is that what's happening? Not having enough oxygen? Why don't I hear more from more people? What about Syed? What about Victoria, Mustafa? What about the rest of you? What do you think? So 1. What else here? 2. I cannot surprise you, can't I? Huh? So okay, let's say this. Of course, you can say all sorts of things, but why? Where do you add the armor? And of course, why? And Carolina, today I haven't heard from you at all. Interesting. Exactly. So this is, look at it. Here is the poltergeist. Here is where change will happen. And here is where change happened. Here is where change did not happen, right? So the airplanes that received damage in this area did not come back. That's where you need more armor. Do you understand? That's the same thing that's happening over here. The poltergeist in this case is the derivative. What functions does the derivative leave alone, does not bother, doesn't touch? They end up to be extremely important. Just like with the airplane. You understand? So that's a philosophy that with experience you develop. It's called searching for the invariant. Whatever hasn't changed is very important. It's very frequently the key to solving complicated problems. Good. So that's why, so then why this equation? Why 0 equal to 1? Clearly one function is known to us. If I take the derivative of 0, it's going to be 0, right? So that would solve this equation. But the function at 0 would then be equal to 0. So 0 is one invariant, but that's a trivial type of environment. What about non-constant functions? So another reason is, of course, I'm hoping that it will be exponential. Exponential to the power of 0 equals to 1. You follow? So that's why I make those abstract conditions. But in these conditions, there is no mention of anything that's called exponential function. So then again, we investigated whether or not the function, if you cannot think abstractly, think of e to the x, could it be a polynomial? Okay, and then we verified whether, let's say, could it possibly be a polynomial of degree 2? Of degree 2. You remember, guys, from last class? Let me know, could it be a polynomial of degree 2 or less? In other words, could I possibly figure out what's e to the x by figuring the coefficient a0, a1, and a2? You know, there's some number here, some number here, some number here, and now this polynomial is able to model everything, every calculation that you can do with e. And why not? The yes or no is less important than the why.
Is it because of the dependent is 0?
0, yes, but be more clear about that. You understand, guys? One thing you're trying to do is, if you are able to clearly express something, that means you understand it. If you are not expressing it clearly, then the understanding is not strong enough yet. So Rafid, yes, right? So one thing is, how do you think? You need to know your objects. How do they react? And ratio, yes, right? So we are searching again. E to the x is in some sense a fiction. We don't know any e to the x, right? We don't even know exponentials. Let me prove to you that you don't know exponentials, actually, right? Do you understand what this means? Let's say if I ask you to calculate 2 cubed, do you understand what that means? That means that's something that you can calculate. It's 2 times 2 times 2, correct? You can do that. That's 8. Good. You can do that. Also, if you can also calculate this, the exponent law, right? The exponent law, for example, if I have 2 squared multiplied by 2 cubed, you can say this is just multiplying 2 by itself twice and then multiplying 2 by itself 3 times. And the combined product is 2 multiplied by itself 2 plus 3 times, correct? So you have this exponent law. From there, you might say, aha. From there, I have 2 to the power of x times 2 to the power of y equal to 2 to the x plus y. The problem with this is that you just verified that this is true for integers. Yes? What does it even mean? What do the powers even mean when you're not using integers? Okay? So you'll ask yourself, what is this? Right? What is this exactly? I mean, you might have been told it's a root of 2, but or you always ask, if you say it's root of 2, tell me why do I say 1/2 is root of 2? Why is that true? It's not arbitrary. No, not somebody just wrote 1/2 above a number will be the root of it. Okay? And even if you can justify that this is a root, tell me this. What is this? I multiply 2 by itself square root of 7 times. What exactly do you mean by that? Okay. So when I say something like the exponent law 2 to the x times 2 to the y equal to 2 to the x plus y, I'm not even sure this has any meaning at all. Okay, so exponents exist to me only kind of by this myth that I verified it for integers, and then I hope it somehow, it was taught in school that it might work for other values, right? If you put 2 to the power of root of 7 in your calculator, it will spit out a number, but what is it doing, right? Good. You understand what I'm saying, guys? It's not, what I'm saying is not vague, right? You understand what I'm trying to instill a sort of, well, do you realize what you have understood in the past and what you have not understood? And even something as exponent law, you never understood it. I'm pretty sure nobody here did. Okay, so this entire thing is mysterious, but it's somewhat easier to understand what it would mean to take a derivative of a function and get the same function back. Okay, so this equation is more meaningful than exponents. Okay, I just kind of arrived at this idea, and we have it. We essentially want to know what function has derivative equal to itself. So it could not be a quadratic polynomial. Now why? Because if this function, look at it, at 0 it's equal to 1. But that means that the polynomial at 0 will have to equal to 1, correct? If I were to plug 0 here, a0 will be 1. But if I take derivatives enough times of a quadratic polynomial, like here I need to take 3 derivatives. Whatever quadratic polynomial I take 3 derivatives, it's disappeared to 0. But if I take the derivative of a function that is not affected by derivatives, it stays the same. And at 0, it will be 1. So it cannot be a solution to this equation. Before I continue, guys, do you understand? Right? I think I'm explaining clearly, but maybe like, oh, you're entirely confusing me, professor, right? Is that that thing, or do you understand? I like to confuse you, sure, but I'd like you to be confused so that then you realize what you were confused about, and now it's no longer confusing. Guys, do you understand what I just said? Write in the comments, because I cannot see most of your faces. Or show me your face and then nod. That would be nice. Thank you. So do you understand why it cannot be quadratic? Because I know polynomials. Take enough derivatives, a quadratic polynomial vanishes to 0. But a function that is not affected by derivatives will not vanish. And at 0, it will still be equal to 1 at the end of the process, right? You understand? Beautiful. So then could this function possibly be a cubic polynomial? No, it could not. Why can it be a cubic polynomial? Because why? You see, if you find here, this is how you do it, right? Like, why am I not this pen? Because I'm not as skinny as this pen, right? This pen is skinny, I am not skinny. So therefore, this and the pen is not the same object. I found one property that's true about the pen, and it's not true about me, so we are different. That's the metaphysics, right? And you are right, Pavel, the derivative will be a square function. That's good enough, but you want to reduce it to absurdity, you understand? Because you start wondering, how can a square not be equal to a cube? You're so often surprised in mathematics. How do I know? Maybe a cubic function can be modeled with a square function. You understand? You think, oh, what a weirdo you are, right? But yes, but you get very, very paranoid, because again, if you stay with me, I will show you paranoid with probability. You are always have to be on your guard. Because when you are not, you will make mistakes, and you will realize mathematics is always going to surprise you. Okay, so that's called the reductio ad absurdum, reduced to absurdity. Take enough derivatives of a cubic and it's 0. Yes, 0. And forget about comparing different polynomials. 0 means that if I evaluate the fourth derivative of a cubic, I put in 0, I'll get 0. But in this equation, if I put 0, I should get a 1. So there is a difference. You understand how I reduced it, guys? the function, if I take enough derivatives of a cubic, here it is, right? Take derivatives of the cubic, it's identically equal to 0 for all x. But a function solving this differential equation at 0 equals to 1. They are not the same. I cannot at 0 equal to 1 and at 0 equal to 0 at the same time, because 0 is not equal to 1. Or does it? Okay, do you understand? And now could it be of degree 4 or 5 or 6, or I can solve it right away for all degrees? Could it be of degree n? Do you understand what this n means? It's just talking about all possible degrees simultaneously. The bigger the degree, the more freedom I have to choose different coefficients. Could it possibly be of degree million? Or degree 1,000,007 or trillion or something, right? Could I just have enough coefficients and then it will be, it will work with a polynomial? Could that work? You understand what I'm asking? Yes, guys? Could any polynomial solve this differential equation? No, Rafi, thank you. And no, Rachel, thank you very much. What about the rest of you guys, right? Do you understand? Why, let me ask you this, guys, and I want to see many answers. That's so why couldn't a polynomial of degree 100 solve, in other words, you have 100 coefficients. How do I know right away that a polynomial of degree 100 could not solve this differential equation? How do I know that? You can write it in one line, it's not long. Well, yes, and I would say, how do you know that? You see, reduce it to absurdity. Why are you? How did we figure it out for? Yes, Rafi, that's exactly right. You understand, guys? It's very clear, simple logic. If it's a polynomial of degree 101, right? Look at it, right? When would the leading term disappear? Take one derivative, it's 100. Take another derivative, it's 99, right? And onwards. After 102 derivatives, it vanished completely to 0. Do you see that? Guys, do you all see that? It's a simple thing, I think, but do you see that? If not, then we are not grasping it. Take a polynomial. Take any term. Look at any term. Right? The term of degree 5. Just look at the term of degree 5. Because between them there is addition. A term of degree 5 will disappear. For one derivative, it's 4. Two derivatives, it's 3. 3 derivatives is 2. 4 derivatives, it's 1. 5 derivative, it's constant. Another derivative 6, the constant is 0. Do you see that? Because basically you go all the way to x to the 0, and then when you take derivative again, it's the derivative of a constant is 0. Yes? You understand? If I take 5 derivatives of x to the 5, I arrive at a constant because it's 5, 4, 3, 2, 1. Now x is 0. X is to the power of 0, so it's now a constant. Now take another derivative of a constant, it's 0. So the 5 term will disappear after 5 derivatives, right? So then all you have to pay attention is when does the biggest term disappear. If the biggest term is of degree 100, it will disappear after 100 derivatives, and all the others disappeared before. And the function is identically 0. You understand, guys? Look at it, right? I think simple, clear, correct? Everything disappeared. So if a polynomial is up to degree 5, all the other terms disappeared before I took the 6th derivative. And the last term disappears by the time I take the 6th derivative. So if it's a polynomial of degree 1,000,000, all I need is to take 1,000,001 derivatives and it's 0. But no matter how many derivatives I take of my function, it doesn't change. If it's impervious to derivative. It's like what you say in Russian, как с гуся вода, like water from a goose's feather. It just doesn't stick. Derivatives, it's a creature, it's a dragon, it's impervious to derivatives. Good? I'm making sense, guys. Yes, I mean, I make sense, I think, to 5 people. What about the remaining 25? Good. And it should not disappear, guys, right? I'm not pouring water into a bucket with holes, right? It should stay there. Good. Wonderful. So here is the thing, guys, and here is where you remember Indiana Jones movie. Remember the Holy Grail. We right now understand we cannot possibly have a finite polynomial. But polynomial is all that we love, it's all that we know. What's your leap of faith? I underlined this. You know me already, right? What is the leap of faith that we make now? You remember Indiana Jones, guys, right? You remember the Holy Grail. Do you remember the leap of faith? Don't tell me you haven't watched Indiana Jones. You don't watch it? My God, what sort of creatures are you? You should make it one of your assignments. You watch Indiana Jones. The old movies. What do you mean so many? There are 3. No, that's not considered. Watch the 3. Whatever came afterwards is bullshit, right? Watch the original Indiana Jones. Yes, it's very helpful. It's also how I view my existence. You know, when the German guy drank, was it German? I don't remember, but he drank this water from this false Holy Grail. Do you remember what happened to him? That's what I see when I look at by myself in the mirror. So what's the leap of faith that you take?
Isn't the leap of faith is when you kind of skip over a certain number and then use its like a decimal point but close to the number, but it's not that number.
But we are dealing with a function. So when you say number, maybe what you're saying is right, but describe it. What exactly is the leap of faith? It cannot be a finite polynomial, yes?
Yes.
So, but you understand, guys, you have to know what you want. If you ask for something, know what you want. And if you ask it correctly, you will get it. I guarantee it. Okay. So, nobody takes it? Okay. The leap of faith, guys, is that if it's not a finite polynomial, then let's try an infinite one. One that never ends. And let's see what we get. Do you understand? Here it is. So let's try to look at a function that's an infinite polynomial. What do we know about this function? Take the derivative of it, and the function is not changed. And plug 0, the function equals to 1. Now, what I want you to do is figure out the coefficients. How do I figure out A0, the first coefficient? Can you see, guys? First coefficient, A0. How do I figure out what it equals to? Help me. What's the easiest thing to do? It's a scary long expression. What do I put instead of the x to make it less scary? There is even only one thing I can put instead of the x and know the answer to. This function is, I'm supposing this is my function, the mythical function whose derivative equals to itself. I know something else about this function. I made the requirement that this function evaluated at some number is equal to 1. What do I get? What do I put instead of the x to get 1? Zero. Yes. What happens if I plug in 0? Look at it, what happens. If I plug in 0, everything except for the first coefficient is annihilated, and the function is equal to 1. So I know that A0, here it is. I plug 0, I get 1. Everything else is 0. So I get that A0 must equal to 1. Do you understand, guys, what I did? Look at it carefully. I plug in 0, I get 1. I plug in 0 into the right expression. Everything but the first term is annihilated to 0. So I have A0 is equal to 1. Are you with me? I figured out my first coefficient. Isn't it nice? Watch it carefully, guys. I'm showing you the magic here, right? It's very, very important idea. If you ever do anything with mathematics, make sure you get this idea. And you read my email. I'm not sure if you thought of it in any way, right? You often think this way: if I don't, if this is not helping me, if A is not helping me get B, then I don't care about A. That's the way of that's a common way of thinking. That's a way of thinking that you have if you have not studied probability. It's like your ears don't care if you get punched in the nose. Because, well, what does it matter to the ears? The ears are not damaged, okay? But if you wait or are interested in my questions, I will show you something incredible after class if you stay. I don't think anybody or too many of you will stay, but I try. There are definitely in the other class 2 people wanted to know. Anyhow, let's go on. Guys, before I continue, you need to know what is n factorial. Right? So 3 factorial means multiply the numbers 3 to 1. Multiply all digits or all integers up to the number 3. 5 factorial means 5, 4, 3, 2, 1. Multiply them all. And in general, n factorial is, if n is a positive number, it's n minus 1 and minus 2 all the way to 1. 0 factorial is defined to be 1. Okay? So here again, we are solving for the coefficients. You understand? I plugged in 0. And I got the function that 0 is equal to 1, and only A0 is the surviving coefficient. So here, A0 must equal to 1. Yes? Yes, Karolinushka. Yes, who else is there? Dante. Yes, Joshua. Wonderful. Yes, yes, right, guys? Not just yes, you're not yes people. You are people of understanding, yes? So here is my next question. How do I figure out the next coefficient A1? What do I do to figure out A1? And the answer is pretty simple, guys. The only thing you know about the function is how to take derivative of the original function f and plugging 0 into it. That's pretty much all you know how to do. So there are not many options. What do you do to figure out A1? Why anti? I need to figure out A1. What do I do? Remember how the function looks like. Here is the function. Look at it. Suppose I wanted you to tell me what is A1. And this function, you have the hypothesis, this function, when you take the derivative, is not changed. And when you plug 0, you get 1. What do you do? Exactly. Find derivative. Do you understand why finding derivative will help us, guys? Look at it. What happens if I find the derivative? Here I do it, right? Take the derivative of this function. Look at it. Do you see? Take the derivative of this function. That's the same as taking the derivative of this infinite polynomial, assuming, of course, each term, you know how to take derivative of each term separately. A derivative of a0 is 0. Derivative of a1 times x is a1. You see it? Because the x disappears. You remember that? That's the shortcut that we learned, I hope, guys. I hope you learned it, right? We practiced with the definition. And of course, to prove the shortcut, one of the reasons we did it. It's a1. And take the derivative of a sub 2x squared, that's 2a2x, etc. Right? But this function is impervious to derivatives. That means that if once you take the derivative, if it equals to this infinite polynomial, it must be the same function. Yes? And now I can plug 0. A1 is now an isolated sheep. I can get it. Right? Plug in 0, and what do you get? Plug in 0, everything is annihilated except for a1. Do you see that? Isn't it cool? I figured out a1. It's the coefficient next to x must also be 1. If you understood this, tell me what's the next step. Here is my function here. I need to figure out a2. How do I do that? Not just of a1, but Miriam, but of the entire thing. Yes, and it's 2 times that. You take the derivative again. You understand? It's almost, if you understand what you're searching for, the procedure suggests itself. You don't even need to, there's not many things you could do. The function, you don't know what it is. You know that under derivatives, it's not changed, and plugging 0 gives you 1. That's all you know. Yes? So continue taking derivatives and plugging 0. If it's an infinite polynomial, it will move the coefficients and eventually isolate them in being constant. Yes? So here is that process. The second derivative is the derivative of the derivative. This is the first derivative. The derivative of the derivative now isolates 2a2. Everything else has an x. Do you follow? And now when I plug in 0, everything is destroyed except for 2 times a2. So we have 1 equal to 2 times a2, which means a2 equal to 1/2. Are you with me? I found the first coefficients. Now, what about the third coefficient? Look what happens. It was second coefficient used to be x squared. Then what is this 2? The 2 drops down, then the 1 drops down, then there is nothing else next to it, right? So that's when I stop. So for x squared, I take 2 derivatives. One derivative, it's 2a2x. Another derivative destroys the x. You understand? You are seeing this second term. After 2 derivatives, it's moved forward. Or forward, I mean, of course, in this direction, right? It's being isolated after 2 derivatives. 3 derivatives kill it. 2 derivatives remove its x. You understand? You want to remove the x. Everything else will still have some x. And therefore, if you plug 0, it will be eliminated. And this coefficient will not have an x. Of course, Pavel, please ask your question.
So I understand I'm getting what we're doing here, but I kind of forgot what are we trying to figure out?
We are trying to find a function that is not changed under derivatives.
Okay, and this is related to that?
And this is finding this function. In other words, we want to understand what is e to the x. It seems that e to the x, this mystical beast, when you take derivatives of it, it will not change. But the it is a very weird it, you understand? We don't understand exponentials, really. If you cannot think abstractly, you can imagine this is the exponential function. We're just finding e to the x, what it equals to, okay? But if you can follow the more abstract reasoning, we're just searching for a function whose derivative is equal to 0. And I will give you examples below to hopefully eventually convince you that it's important. It of course, you know, the more you know of it, the more you realize that's a very important knowledge that you have here. In entire mathematics, there are things that I see again and things that I never see again. There is nothing that where I've not seen e to the x. It's always appearing. Right? And the reason it's always appearing, I gave you a very rough, this airplane example. Do you understand what I mean? Because derivative is an important process. And the derivative is like that poltergeist. In understanding the poltergeist, you want to know what it's not touching, what it's not changing. So the importance, it would be one major reason is that derivatives does not change e to the x. Okay, and I want to understand this object better. What is that thing that's not being changed? Good. You understand, guys? Don't forget those thin, what do you call it, strings. Don't forget those strings. What connects it? What is it that we're seeking? Why do we seek it? If it's obvious to you, then you can easily retrace the steps. Are you with me still, guys? Right? You understand how I got the 1/2. Now I'm asking you to get. Tell me what's the coefficient a sub 3. Thank you, David, but be careful. Is it 1/3 or something else? Pavel, you are right. 1/6. Do you understand how it's 1/6, guys? Guys, can you train your mind? Can you see it in your head? I'm focused on a sub 3 next to a to the power of 3. That's how I'm focused, right? So how many derivatives do I take? I take one derivative, it moves to the left, right? One derivative drops the 3. So now I have 3 a sub 3 x squared. Yes? Don't forget the 3. Now I take another derivative. Here it is, guys. Do you see? 3a sub 3 x squared. Now take another derivative. The 2 drops down. Don't multiply it out because you want to notice the pattern. It's 3 times 2. Do you understand why it's 3 times 2? Because you are using the power rule for x to the power of n several times. It's the power rule when x is raised to the power 3. Then it's the power rule when it's raised to the power 2. And then I need to take one more derivative to get rid of this x. It's now x to the power 1. So it's 3 times 2 times 1. In particular, it's 3 factorial. Yes? It's 6, it's important, but more important is the pattern. It's 3 factorial. You see that? 3 times 2 times 1, a3. Now I can plug in 0. That's the same as plugging 0 to my original function, and that gives us 1. Exactly, James. Beautiful. But not just because you see the pattern. Do you see it from scratch? Do you see how I actually see the powers dropping one by one? So let's say if it's x to the power of 7, then it will be 7 to the 6, 6, 5, 3, 2, 1. And once I drop the 1, there is no x anymore. Take one more derivative, it's 0. But now you have just the coefficient without the x. You understand? Do you see that, guys? If you take Calc 2, I hopefully you will. I'm saving you a lot of effort, not just in Calc 2, but in general. I mean, you want to think about those objects. Okay, so a sub 3 is 1 over 3 factorial. And in general, you see, I showed you 2, 3, but in general, how do I find the nth coefficient? Nth meaning I can come up with a procedure to find every single coefficient simultaneously. When I say nth, I mean second, third, fourth, fifth. I solve the question at once for all infinitely many possibilities. Clearly, if it's x to the power of n, I will need to take n derivatives. Do you agree? N derivatives will bring will eliminate the x, and we'll just keep n factorial times the coefficient that I had before. And now when I plug 0, everything else has an x. It's disappeared. So I have that the nth derivative at 0 is n factorial a times n, but the nth derivative is equal to the function. It doesn't change. And then if I plug 0, I get 1. So I get that a sub n is equal to 1 divided by n factorial. Do you understand what I just realized? And below I will show it. This is the function written out. Look at it. This is the function written out. You see summation. This means summation from n equal to 0 to infinity. It means plug in n equal to 0, plus plug in n equal to 1, plus n equal to 2, and go on forever. Yes, Rafid, n factorial. Do you see why it's n factorial? It's because you apply the power rule. Power rule is when you drop the power of x. That's if you took calculus before, that's what you were trying to do all the time here, right? If it's x squared, take derivative 1, it's now 2x to the power of 1. Take the derivative again, it's now 2 times 1 and x to the power of 0. So there is no x anymore. Yes? So if I have it with 3, it's 3 drops down, then it's to the power of 2. 2 drops down to the power 1, 1 drops down, like over here, 3 to 1, and there is no x anymore. Do you see that? Here is with the 3. So first 3 drop down, there was this coefficient and x squared. Take another derivative, and here is the other derivative. There are 2 drop down, and there is an x. Take another derivative. This has disappeared, but an x is now to the power of 0. It was 3 times 2 times 1. That's the n factorial. If I, in general, for an nth term, if it's x to the power of 100, I will take 100 derivatives, and it will drop 100, 99, 98, all the way to 1. So it will be 100 factorial times the 100th coefficient. You follow me, guys? Look at that. It's extremely natural. If you understand what you're seeking, what is it that you want, what is it that you try to understand, it's extremely natural. And there were questions. I remember somebody in physics asked me a question, and I did not know the physics interpretation of it, but I was so happy because I was philosophically thinking about calculus, what it is, I was able to solve this question. You understand? I mean, what you want to do, I hope that's what you want to do, is not to memorize formulas, because that's useless. It's a waste of your mind space. You want to incorporate philosophy into your being. You want to incorporate a particular way of thinking about everything you see around you. Okay, and this has it has a particular viewpoint to what is everything, right? It basically, to me, calculus is this view, is that what you see around yourself is a giant Lego block set. You understand? What you do is you build up very complicated words out of Lego. So pretty much when I think of calculus, I think of Lego. Have you ever played Lego? Did you enjoy it? That's what calculus is. So the question is, what can I create out of very small Lego blocks? When you do differential calculus, you're asking, what curves can I create with Lego blocks? If you're playing video games, you can say thank you to calculus, because how do you make a computer simulate a person or simulate a fabric? Let's say this is a fabric, right? What you do is you build it up of triangles, called triangulation, a triangular mesh. The triangles, if they're very tiny, you don't notice them. They're microscopic, right? They're small, but it's very easy to mathematically manipulate them. Yeah, so many polygons, precisely, right? So that's calculus. That's like building out of surfaces, building something complicated, out of very simple surfaces, just many of them. So that's what calculus is doing. The fact that you see me on the screen, I'm made of tiny pixels. So all the colors you're seeing are made of just a few colors. That's calculus. That's calculus thinking. Build up complicated things out of very simple ones. Okay, that's all of calculus in a nutshell. The question afterwards is the specifics. What are the simple things in a particular context? If I consider curves, the simplest curve, the simplest building block is a line segment. So I'm building curves out of line segments. You understand? And it's useful in describing classical physics, and not just classical physics, every physics, because up to now, there had not been better descriptions. So quantum physics is described in probability, and probability is using calculus. Okay, and other math ideas, they have other philosophies. Probability feels like an entirely different thing, different philosophy, different viewpoint. Right? If you study, say, I listen to this lecture, that's what I mentioned, Hans Duhr, right? And he was a Heisenberg student. He received, I don't know what it is exactly, the alternative Nobel Prize. Maybe it's the Nobel Prize for losers, I don't know. But is this guy, and he received this Nobel Prize, and he had this very strange theory. That basically says that matter is a fiction. There is no such thing. So you think you are built of matter, whatever it is. You believe in materialism. That's materialism is a fiction. It was a sort of monist. What exactly does it mean? It's complicated, but I understand. I think it's like sniffing too much probability. You see, it's because of this. You see, you look at this atom, right? You think it's here, but that's only a probability cloud. It's very likely to be here, but it could also be here. Unlikely, but it's also here. And even bigger, it could encapsulate everything. And basically, the entire universe is the atom is in the entire universe, and the entire universe is in the atom. You understand? So it's what you call probability fields. If you are interested, I will tell you after this class. I will give you one problem or two problems, and I think those are problems that will change your philosophy on life. if you understand what they mean. If you wait, the questions I asked of you, let's see if you can answer them. Anyhow, guys, sorry for the tirade. I'm trying to keep you excited. I'm not sure if I'm successful, but I try. I try. So back to this problem. Do you understand what we just figured out? Because I believe there is a function that's differentiable many times and the derivative does not affect it, I was actually able to come up with a formula. Here is that formula written in sigma notation. That's a convenient notation. It just means plug in a number and 0, then update this number to the next and add. You see, n equal to 0, it's this expression. N equal to 1, it's this expression. N equal to 2 is this expression. It just goes on. This is my function. And here is what I just showed. If you first of all, let's consider, let's see if this function okay, so are you there, guys? We will learn about antiderivatives. They're extremely interesting things, right? So that's later. Let's see if this function works. Does this infinite polynomial satisfy the requirement that at 0 it's equal to 1? First of all, right? Well, clearly, plug in 0, only 1 survives. You see, plug in 0, everything disappears, but 1 survives. Now, what about the derivative? Will it be the same if I take the derivative? Well, I take the derivative here, 1 disappears, x becomes 1. 1/2 x squared becomes 2 over x, so 2 over 2 times x. 1 over 3 factorial x cubed becomes 3 over 3 factorial x squared, etc. And now when I simplify it, this is just 1, this is x, this is 1/2 x squared, this is 1 over 3 factorial x squared, and onwards. Because it's infinite, it ends up being the same thing I started with. Do you understand? I took the derivative, it's the same thing. So it seems to solve our equation. And here is what we understood. Even though this quantity, guys, I'm trying to push some very abstract, confusing idea here, right? This quantity, you might think, oh, it's an exponential, but you don't understand exponentials, okay? You don't know exponential. Do you understand what I mean by that, guys, that you don't know exponentials? You don't know exponentials because you cannot tell me what is, let's say, 2 to the power of root 5. If you cannot tell me that, you don't understand exponentials. You cannot even tell me what is 2 to the 1/3. So some of you learned it's the cube root of 2. But why is that the cube root? Why 1/3 represents the cube root? If you cannot answer that, then you don't understand. We can answer a few of those questions without calculus. I did. You see, when I was doing pre-calculus, I actually asked myself, and I was able to explain why. I can do it. I'll show you afterwards. Why 1/3 represents the cube root. I could not explain this thing. See, I don't know what it means, right? And I didn't even notice it, to be honest. In pre-calculus, I didn't realize what this thing is. I never considered it, but I did think about it, and I was able to explain to myself what's the 1/3 thing. Why does it equal to the cube root? But you see, because you don't understand those operations, let's say, then you don't know exponentials. But you do understand, hopefully, what is this operation supposed to do. You don't carry it forever, you just truncate it. You say, well, that's an approximation. Let me carry it to the 5th power, or to the 7th power, right? Or to the 12th power. And then I just stop doing it, and I'm hoping that what I get is good enough. It's an approximation. You understand? That's how you carry out calculations. Good? So, again, I'm sorry if I confuse you because I try to push way too much. I'm trying to shake you maybe too much, right? This thing is equal to this thing. What is this thing? And I would say from a purely theoretical point of view, it's something whose derivative is equal to itself. And at 0, it should equal to 1 because I have this faint notion that 2 to the 0 equals 1 and 3 to the 0 equals 1 and everything to the 0 except for 0 should equal to 1. You understand? Pavel, not exploding your head or the rest of you, right? Do you follow or am I being too much here? I'm asking way too much, right? My God, what are you doing to us?
No, I'm just stretching.
And you, Alisa, do you understand? Yes? Honest, you can talk to me. You can say, what the hell are you doing to us? You're torturing me, right? I understand, right? I hope, though, that you are overcoming something. I'm hoping I'm explaining something and not just making you entirely confused. I try to push you, I try to yank you several steps up the mountain. You understand? I want you to be there because it's truly high. I'm not at the top of the mountain. Maybe there is no top. Good. So here is, guys, what I just verified. If for a moment I forget about this nonsense that I said, this is e to the x. I am able to calculate it, which means the number e that I claimed is between 2 and 3 can be calculated like this. It's 1 plus 1 plus 1/2 plus 1 over 3 factorial plus 1 over n factorial onwards. And that means I can approximate it. Here is an approximation. Let's say take e to be 1 plus 1 plus 1/2 plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial. If I sum up those terms, I get something like 2.71, which is a number between 2 and 3. Do you see, guys? I was hypothesizing there is a number between 2 and 3. This process, actually, because I believed in it, I am able to find it. You see, I'm finding a number between 2 and 3. If you plug in the calculator, you plug, let's say, the 1000 for this approximation, you get 0.997. Do you understand? You get something close to 1. Now let's do one more term. Let's add the 1 over 6 factorial. You add up 1 over 6 factorial, it's 2.718. You understand? And what do you get when you raise it to a number close to 0? To the 1 over 1000, you get 1.000396, even closer to 1. Do you understand what I'm telling you, guys? Just because you believed that such a thing exists, isn't your mind just exploding? You believed, you made the leap of faith, and this thing becomes real. You understand? What you believe becomes reality. Do you understand what I'm claiming, guys? Right? If you didn't believe, if you didn't make this leap of faith, it doesn't exist to you. What do you think is root of 5? Root of 5 is also, it feels like that. It's because you see, in some sense, why do you die if I drop a huge brick on your head? It's because you believe that you will. If you are interested, I will explain, right? If you are, of course, right? So if you decide to stay with me, I'll show you. Well, you might think it's a nonsense, but trust me, you see, at my better days, it worked on several pretty girls in philosophy classes, right? Oh, it did. It got me, to fulfill all my practical purposes. So it's very practical, guys. Learn it. Good. You understand? I mean, here is the thing. If people like to hear interesting things, right? In the philosophy class, I could always tell things that they would never think of because they don't understand anything in mathematics. And mathematics is very weird. Weirder than me. Good. So, do you follow what I'm saying, guys, here? There are so many amazing things there, just if you bear with me. And this is the optional section. It's only optional because I do not know. You were supposed to know in precalculus the binomial theorem, but I don't think many of you do. If you bother actually to read my probability notes, they're not very difficult. You can understand it. Just 9 pages each lecture. I can explain to you what is probability, or try to. Okay. And this is this section. What I explain is how do I know now, once I have this formula, how do I have this additive property? You understand? So the additive property works for any x and any y. So I can understand what it means. For example, what does it mean to take e to the power of root 2, right? Or let's say, what does it mean to have e to the power of 1/2? So e to the power of 1/2 simply means this. Means you take 1 plus 1/2 plus 1/2 times 1/2 squared plus 1/2 times, not 1/2, sorry, 1/6 times 1/2 cubed, and you can decide when to stop. You understand? This process now, when you put 1/2, is now very simple. Right? You just don't carry it to infinity, carry out to degree 6. It's going to be a very good approximation. You understand? That might be something that your calculator is doing. You get it? You can multiply those numbers. Those are not such big numbers. You can carry out this calculation. You with a piece of paper can do that. Yes? Guys, I see some faces and it looks like you are gasping. I wonder, either you are saying, oh my God, how interesting, what a revelation, or you are fish outside of water and you're suffocating, right? One of the or the other is happening here. The latter or the later? Do you understand, guys, what I'm trying to do here, right? So, and then with this expression, I try to explain to you this property. This function has exponential. You see, look at it. The function evaluated at x multiplied by a function evaluated at y ends up being the function evaluated at x plus y. That makes it have the exponential property for integers. You understand? Here is the exponential property for integers. It means that f evaluated at an integer p is just the function multiplied, the function at 1 multiplied by itself p times. And this makes sense. And now it also makes sense why, if this property holds, why it will be to the power of 1/2. Because basically, when you say e to the x, you're saying is this function f of x, this infinite polynomial. Okay. So if you can verify, it's not hard, by the way. It's only if you know, you just need to know binomial theorem. I can then explain why it works. But because you don't, I am not going to explain today. So if you have f of 1/2 times f of 1/2, that ends up being by this additive property that I proved not just for integers, I proved them for all numbers. It's end up being f of 1/2 plus 1/2, which is f of 1. In terms of symbols, that just means that e to the 1/2 multiplied by e to the 1/2 equals to e to the power of 1. You understand? Which makes e to the 1/2 equal to the square root of e. So that's where the square root is appearing. Yes, Nassim, please talk.
Professor, so if we have f1/2 over f1/2, it will be f1/2 minus 1. No, it will be f
yes
1/2 minus
right.
1/2.
Yes, which would be 0, and at 0 it will be equal to 1. Okay, so again, guys, I am overzealous here. I might be doing damage to you by just confusing you here, but that's only because well, let's say this, okay? If you don't understand it, just imagine that what we have accomplished is we figured out that e to the power of x is a polynomial. Okay. If you understand my my deeper statement is that e to the x does not exist. Exponential functions, you don't understand them. But this behaves like what you expect of exponential functions for integers, but this is also generalizable to all other numbers. Do you understand what I show? What is the exponential property, guys? Exponential functions have this property. Do you understand? Whatever it is, you have a to the power of 3 multiplied by a to the power of 2. Is a to the 3 plus 2. This is obvious because this just means multiply a by itself 5 times. Yes, you follow what I'm saying, guys? If the power of a number is an integer, that's just multiplication. But when the power is something like a fraction, let's say like 1/2, it's no longer obvious what this is supposed to mean. Okay, you can this still can be explained, and it's even less obvious if what you're using is if you're raising a to the power of root 7, for example, right? What is it that you're doing here? Now, the polynomials, they can multiply all sorts of numbers, right? It multiply adds all numbers. So, for example, if I'm saying this, right? If I'm saying, let's say, e to the power of root 2. What am I truly saying, guys? Say the power, it's whatever. What I'm truly saying is this. I'm saying 1 plus root of 2. Plus 1/2 root of 2 squared plus 1/6 root of 2 cubed and onwards. You understand? You follow what I'm saying, guys? So this is just notation. What I'm saying is carry out this operation. If you can approximate root of 2, if you can give me an estimate, and I can show you how to approximate root of 2 if you're interested. A very simple idea. If you can approximate this thing, you can just carry out just a regular arithmetic, and you can figure out what this means. Do you understand? Guys, how many of you understand? And how many of you are, oh my God. That's beautiful if you have, right? So if not, then imagine there is an exponential and there is another way to calculate the exponential. If yes, the better thing to understand is that there is this thing that did not exist before. You understand? I just created my first exponential. Because this function works for integers, but also works for every other number. So whatever I did before was in some sense alike. There were no exponentials. You can actually get around it. I can develop the exponential theory, but that involves real analysis. There is other ways to do that. You understand? But as far as you know, exponentials are meaningless things. As far as you know, by the way, taking root of 5 is a meaningless thing because you had never thought about it. You cannot carry out this calculation. If you cannot tell me what's root of 5, if you cannot give me numbers, if all you do is use a calculator, that means the calculator might know what it's doing, but not you. 1 second. Onwards. So this is the optional section, and if you bother, I will explain. I'll hope you understand it. So now, how are you doing, guys? Are you ready for more? Do you have the strength? What I did before, you should, when you go home, you should solve it. You should figure it out on your own. Just can you derive those results? That if you can, that means you understood. If not, not yet. Okay. That definitely happened with my morning class. My God, I just get so exhausted. So after having this class, I'm so tired, I want to take a drink. Usually, what do you drink? You drink tea, but no good Russian will drink tea without alcohol, without rum. So, yes, Nassim, what would you like to say?
Professor, now we are in chapter 3.3, yeah?
Exponentials. I'm not sure where we are, but whatever is exponential derivatives, we're there. But I'm not exactly talking about what's in the book. I'm covering it a little bit differently. Okay.
Oh.
But yes, essentially we're there. So here is this question, guys, that we have, right? So if you are not enjoying this material, it has to do with E. I'm sure of it. And if you're enjoying it, also with E. And if you are frustrated, it has to do with E. And the fact that I will go and drink something afterwards also has to do with E. And let me explain what I'm going to do. So I will take one glass full of tea and an identical glass full of rum. I will take a sip from my tea and I will pour the rum, mix it until it's, until it's again fill up to the brim. Then I drink, and then I pour more alcohol and I mix it and I drink. Are you there, guys? So here is this question. What's the probability that the last sip that I will take will be that of tea? What's the probability that my last sip will be that of tea? And we are going to solve it together and we're going to make it precise. Do you know the song, guys? All around me are familiar faces, worn out faces. Yeah, when I was staring at my students in the morning, that's exactly the song I played to them because that's what came to my mind. You know the song, yes?
Of course.
If you need to take a break, I will play it for you. If not, let's continue. Why sing that song? Because I have to, that's what I have to deal with, right? I have to deal with it's like, I explain, it's like I'm a shepherd and I'm required to explain this calculus to chewing animals. Like I chew it. All right, it's like moo, and I'm explaining it again, and it's moo. It's very, very disappointing.
Yeah, I'm asking not to why, but who sung this song?
I don't know. I'm not sure whose song it is because it was sung, I think, by somebody British originally. Yeah. So again, guys, right? To me, if you don't understand something, doesn't bother me. I can explain it a million times. When you don't care to understand it, that infuriates me. So let's continue with this idea. Yes. So here is how we run this experiment. Okay, so for simplicity, imagine first that we only have 3 molecules of T and 3 molecules of Rom, and that when I take a sip, I sample exactly 1 molecule at a time. You understand? I remove 1 molecule at a time. So the probability it will be me. I am not a good singer, so it's not a good. Yeah, I can play the YouTube video if you want. Good. So we have 3 and 3. Now, you see the question is, guys, so you focus on molecule number 1. Let's calculate the probability molecule number 1 survives first sampling. Do you understand how it works? I sample 1 molecule from the T glass, and I replace it with 1 molecule of the other glass. Yes? What's the probability that molecule 1 survives to the very end? You understand? That's the first question. I focus only on 1 molecule. I don't care about anything else. What's the probability this 1 molecule will be the last molecule that I will sample? Does it make sense, the question, guys? What's the probability it survives first sampling? First sampling. What's the probability it survives it? Please help me. Okay, so some of you say 1/3, but that's the probability it is picked. What's the probability it's not picked? It should not be picked. So it means either 2 or 3 were picked. 2/3. Very good. Do you understand? 1/3, as you said, is the probability it is picked, but the probability it is not picked first is 2/3. Now, what's the probability? And then 1 molecule it replaces the other that was picked. What's the probability it survives another round? In other words, what's the probability of surviving 2 rounds from here to here? So it was not picked first. It is not picked second. Two-thirds to survive again. So it will be 2/3 squared. Do you understand why? 2/3 times 2/3. I'm assuming you understand why you multiply. If not, of course, we can explain that. So, but what's important is the pattern. Okay. Then what's the probability it survives the next sampling? So it survived. This 2/3 squared means survived first and second sampling. What's the probability of surviving the next? Cubed. Very good. 2/3 cubed. And then the probability it survives here, it's 2/3. Let me just erase this part here. Give me a moment. So surviving this sampling is 2/3 cubed, and then this sampling is 2/3 cubed times 2/3. Okay, I isolated it on purpose. I could have written it as 2/3 to the 4th power, and then the next survival is the same but times 1/2, because now there is no replacement. You understand? So altogether, the probability of surviving all of it is simply 2/3 cubed times 2/3 times 1/2. Yes? With me, guys? Good. So altogether, that's probability that molecule 1 survives. Yes. So it is. It is here, guys, right? So, but probability that the last molecule sampled is that of T is either it's molecule 1 that's last, or 2 or 3, and it's mutually exclusive. If 1 is the last molecule, it couldn't be 2, right? So that means it's times 3. So the answer is if that the first molecule survives is 2/3 cubed times 1/3, and that the last molecule that survives is that of T is 3 times that. So it's 2/3 cubed, which is 1 minus 1/3 cubed. Good. Now that was when I had only 3 molecules. Okay. Can you do the same thing? Let's do the same thing when we have 4 molecules. So you have here is 1 beaker, and you have 4 molecules. And then in the other beaker, we have also 4 molecules of alcohol. Okay, good. So what's the probability that we have first sampling survival of molecule 1? Three-quarters, beautiful. And so let's say it survived 1 sampling. So then there is a replacement. You see 1 molecule got deleted from the other, and it moved in the first turn, right? What's probability of survival again? Exactly. So it's now survival again. It's another 3/4. Yes. Now another molecule is deleted. What's the probability of survival again? Again, it's 3/4. Yes. And again, it will be 3/4. And next, what's the probability it survives again? Now, once it was 3/4, right? So there is another 3/4, but no longer replacement, right? So it's now again 3/4, but now nothing is replacing molecules that disappear from here. So now there are 3 molecules. So now it's 2/3. Next, it is 1/2. And now it is the last molecule remaining. Yes? Now it's the last molecule that I have remaining. So my answer then is what? When I simplify it, look at it. When I simplify it, it is 3 divided by 4 to the power of 4, multiplied by 3/4 times 2/3 times 1/2. And if I cross similar terms, so look at it, 3 removed and 2 removed. So it's times 1/4. So this is 3/4 to the power of 4 times 1/4. Yes? And that's only that molecule 1 survived. So the probability that one of those 4 molecules survives is the same thing times 4. So it is 3/4 to the power of 4 is the probability that T is removed if you have 4 molecules, which is, by the way, the same thing as 1 minus 1/4 to the power of 4. Now, if I have 1,000,000 molecules, what do you think will happen? What's the probability if I have 1,000,000 molecules in each beaker for the survival of T molecules to be to the last? Okay, you understand, guys, what I'm asking? Don't die just yet. You understood what I did with 4 molecules. Can you guess what it will be with 5 molecules, 6 molecules, 7? And the beaker has many molecules. Do you agree? The beaker has huge many molecules, millions, billions molecules, right? So what would that be? Exactly. Well, not to the 4, Rafid. Why to the 4? Yes. Yes. And well, to the power, why to the power of million, not 999, to the power of 1,000,000. Look at it, guys, right? When you have 5, it will be 1 minus 1 over 5 to the power of 5, as you can verify. And then when you, in general, when you have n, a very large n, it would be 1 minus 1 over n to the power of n. Yes? You understand what I mean? So that's not division, it's just, you understand? I mean, I'm just saying if it's n, if it's 5, right? It's this formula, right? And now my question is, what is, that's for one particular molecule. What is then the limit? It's very well approximated because we have many molecules of T, right? What's the limit as n goes to infinity? 1 minus 1 over n to the power n. What is that equal to? Because it's a n is not going to be even a million, it's going to be trillions, right? It's going to be a huge, huge number because there are many, many molecules. What is that limit going to be like? What do you think? Okay, so somebody says 0. So Rafid, if you say 0, that means that there is no chance that the last molecule removed is that of T. Approximately 0. So it's extremely unlikely that the last molecule removed is that of T. That means you think because I'm Russian, it must be alcohol. That's the last drop I take. Uh-huh. So what does the rest of you think? Well, guys, let me help you maybe, right? Well, that's the formula, Christian. That's right. But what's the limit as n goes to infinity? Because n is just it's just a huge number. So let's say, guys, what about this? If I say, well, limit as n goes to infinity. So somebody says 1, okay, maybe wonderful. So we have 1 minus 1 over n to the power of n. And what I can see is that this thing, it goes to 0, yes? Christian, say 1 as well. Okay, so this goes to 0, yes? And then goes to infinity. So then we think it's going to be 1 to the power of infinity, right? So it's inside, it's like 1, and then it's 1 to the infinity because n is large, which this means just a 1 to a bigger and bigger power, which we expect to be 1, yes? How many of you understand why this is 1? Yes, you understand? Yes, Pavel, do you agree with me, right? That's why it's 1. I'm waiting for more people. I need to know if you understood me this far. Because yes, we're kind of getting tired. Well, I'm saying, well, if n is large, 1 over n is almost 0, right? So 1 minus an almost 0, and then this n is very large. So it's like roughly like 1 to the infinity, which is 1. And then maybe if it says maybe it will be almost 0. Again, I'm just asking if you agree with what I wrote, guys. And some people already left. Where are you guys? I disagree. It's fine. You can disagree. You can disagree with me, guys, I hope. All right. Well, it's good if you disagree because this argument is entirely stupid and wrong, right? It is definitely not the right answer. And let me just show you what the right answer is. Let me show you what the right answer is. I told you it has to do with E. Okay, so let me go there. Almost 0, that's what you're saying, Pavel. No, it's not almost 0, not at all. And people are leaving me. Why are you leaving? Too many disappointments? Too many times wrong? It's very interesting. What do you think this thing is? It's actually e to the power of -1. It's 1 over e. It's less than 1/2, but it's so it's closer to 0 than to 1, but it's 1 over e. And I will explain in the next class why, because I think you are exhausted. But you could actually figure it out with a calculator. If you don't know for large n, just plug in some version of n that's large and see what your calculator is saying. So that's one way to get an estimate, okay? So it's good if you disagreed. And let me just actually mention, yes, exactly. We will talk about what it is doing here, this rascal. Let me just quickly mention your birthday. Where is she? Oh, good. Minkowski, we need you now. Yeah, so before you go, guys, we have what? We have people are leaving me, my God, like flies from a dead dog. 27 people, should be more that's staying here. So I asked you for your birthdays. How many people do you think have the same birthday from this class? So how many of you in this class share a birthday? What do you think? You maybe none? All right. So here is what it is, guys. The number of birthdays shared in this class that I found, 2 pairs. Minkowski, October 11th. Who else is born on October 11th? And who was born on January 29th? Are the January 29th people here? No? The January 29th people don't like me. They are winter people. But who else is October 11th? Yes. Yes. You are a winter child, but okay, good. If you like me, maybe you're not really a winter child. And besides, if it's a winter in what is it, in Lebanon, it's not that cold there. Well, you are wrong. You see, I knew with 88% certainty that there will be. Why? Because of E. Let me show you very quickly. I'm not gonna go through the explanation today. There is only January 13th. There is only one. Here, guys, look at this thing. I knew it's going to be the probability that you will not share, that none of you will share a birthday would be approximately e to the power of -2.137, or 11%, 11 to 12% that you will not share a birthday. If enough people replied, the likelihood that you share a birthday once you have 23 people or more is 50% at least. You understand? And you understand that if you do the probability. One person was very interested that we actually spoke about it. In the other class, we moved a little bit further. But I'm not sure they understood more. We just moved further. Maybe they didn't ask me questions. They're black screens, so I don't know. Good? So if you want to, you can, let's see, we're not going to continue much more today since you are tired, I presume. And so what we can do is we can stop the lesson. And if you want to, we can rest a little bit and continue with office hours if you will stay. If not, have a good weekend. Remember what I can show you. Root of 2 or root of numbers. I can show you a very simple, clever, and somewhat silly sounding procedure to calculate it. I can show you several. And then something that you could have actually come up on your own, I think. And then I can show you, we can solve problems from previous exam. We can talk about something that you haven't figured out. So many nice things that we can do. Can I explain E? I can explain much about E, right? But those will be slower. And when we can talk about probability, I mentioned one probability question, guys. If you stay with me and want to listen to it, I can ask you what you think is the answer. and why that relates to not believing in matter. And we can talk why root of 5 what it has to do with dropping a brick on your head, and all sorts of interesting things. Okay, so I stopped the video, guys. I see many already left without worrying about it.